going to continue with the presentation by Oscar Messano. Let me tell you that Oscar is like fencer. He's the one that when we wanted to start with the school, we had several problems. We didn't have funding. There were some companies that believed in our project, and we also needed some administrative structure as regards the tax situation, etc. And he offered the CCAT Labs, which is the NGO he works for. It's the Technology Center for Latin America and the Caribbean, and that is like our home. He also was the founder of the Argentinian Internet Chamber, and he has transferred this information to many, many countries in Latin America. I don't know where he is. I'm talking about him, but I can't see him. Oscar, are you there? A round of applause for Oscar, please. I still didn't say anything. I was talking about your role with the internet and how important you were for us when we started with the school and we needed some kind of space to host the school. And you were so helpful with the organization. So we wanted to thank you. Thank you, because what you have given my contributed to my organization has been also very, very important. It was like a win-win situation. I'm going to move from the light so I can see you better. Hello, you all know me. Good morning to everyone online. And if we can show my presentation, please. A future that is possible. First of all, let me introduce the name of the presentation. If we could divide the future in seconds, there would be infinite variables, but so as not to make it so huge, we're going to say many. Our brain programs our lives as if everything was perfect, functional, but it's not the case. We have a possible future with many variables that can change. And this has to do also with technology. That's why I use this name for my presentation, this title for my presentation. I have split my presentation in three. The past, because it's important to know how we got here. Present, because I want to talk about the situation today. And the future, because as the name of the presentation says, it's only possible. We don't know how it's going to be. We can imagine it. We can imagine the future, and then if we are right, we're going to be like a guru, and if we are not, we're going to be just like another person. The 17th century, the steam machine was invented by James Watt. This changed the world in a revolutionary way, and it brought about some interesting situations that have to do with the change in production, from everything involving the textile fields with intensive manpower and with the use of the steam engine. We had the first industrial revolution in the world, which started in England, and it was finally spread through the rest of Europe and later to the US. This brought about important social changes, specifically in England, mainly in England, with some different kind of demonstrations, but also it changed the world of, or the world of lives and the livelihoods of people, production, the industries. And as from there, revolutions started to take place. This was the first industrial revolution that the world had. We also need to say that the steam engine was developed using something that the human being have been using for many years, that is heating water. But James, what he did was to use steam there in order to move the machines, and that changed the world. But as any other kind of invention, many people say that they invented it and he had some problems to obtain their patent because there were already some steam engines that were being used. But what makes the invention true is the patent, and he was the one who did it. The second industrial revolution was in the mid-19th century, when the US started changing production from manual to the assembly line production. Ford was the one that decided that workers needed cars, so he developed an automotive industry that used the assembly line, not with robots, but with human beings using mass production. It was copied by the rest of the industries, and it grew. And that revolution extended to Europe and then to Japan. And there was a huge growth in all the industries there, because at the time, the chemical industry, the oil and gas and transportation industries had a lot of changes. We had the transatlantic vessels. There was a huge change by the use of steam in transportation. There were huge advances in chemistry, in the oil and gas industry. They started using oil massively, globally, and companies started growing exponentially. It wasn't the case for labor, because industrialization was becoming more automated. And it is something that we still can see today. The third revolution was a scientific and technological revolution, when we started seeing all the technological devices and products that started helping to develop other products in the rest of the world. It is based on IT technology, in electronics and robots. These robotic arms that we started seeing in factories, in mass production. And it is true that at this stage, I don't agree with this, but this is not the third revolution. The third one is this one that I'm showing you here, 1995, with internet as a business, with those four people who are the ones who developed internet. Since you are not all from the field of technology, I'm going to give you a summary. In the Cold War, which lasted many years after the Second World War, the US and Russia had nuclear arms, and the Americans and the Russians were all the time looking to the sky to see when they were going to be having a missile impacting them, hitting them. And the Americans developed bunkers, and the Russians created the subway that was their bunkers, and they still use it today. The American bunkers are useful to storage things only. And the armed forces in the US had a huge problem. They knew the consequences of a nuclear explosion, and they knew consequences that they may have as regards the environment, but there was a byproduct that was called the electromagnetic pulse, and they were concerned about it. EMP was developed with is caused by the nuclear explosion, but it's going to burn everything that works electronically. And at the time, computing centers were huge, with a lot of terminals connected by cable. There was no microwave at the time. And if a bomb hit a computing center managing missiles, the armed forces were going to be unable to answer to that attack, to that offense. So they asked DARPA, which is the special agency for special products in the US military, to develop a network that would stand a nuclear explosion. And this agency involved these 4 people in what was later on known as Internet. Vinton Cerf and Tim are the ones who developed the Internet protocol. Larry is the developer and operator of ARPANET, which was the name that Internet had before 1995. And Tim was the developer of the WWW later on. But the solution to a strategic military problem was Internet with multiple networks connected. That was the development through the TCP protocol. In 1995, the US government decided that they have been handling ARPANET for many years, that it was too big, that involved too many industrial economic factors in the US, and that it should become something from the private sector. So they developed a non-for-profit organization that was called ICANN. You have heard about it already. And that was the result of going from ARPANET to Internet, and the US government and the private sector in charge of that same network. Why do I say this is a revolution? Because if we consider the previous revolutions, Internet was something so different. In 10 years, Internet was spread all over the world. It was the biggest way of communication for human beings at a very low cost. I know what you are thinking. The internet bill that I pay is not so low. But considering the options at the time, be able to send an email to somebody in the other part of the world and at such a lower cost, it meant a huge revolution for society. When we started with this kind of technology, one of the ideas was that technology was useful if it's useful for society. And Internet was thought for society itself. It gave us a voice. We are able today to do many things through Internet, like to talk, to become what we want to be. Whatever we want to be, we can do it through Internet. We didn't have that before, and that is a revolution. The industry grew thanks to Internet. The information we have available on Internet, nobody can say that they don't know where to search for something. You all know that. But before, we had to go to libraries, find a book, open the book, and look for what we were looking for. I'm not going to talk about that because probably you were not part of that. So that's why I say that this is the real third industrial revolution. Because what it brought about is different to what other revolutions brought about. I'm talking about industrial revolutions, and this is not an industrial revolution. This is a global revolution. It has changed the world. That's why I say that the third revolution starts in 1995. Now let's talk about the one that everybody says is the third revolution, which is this one. We have already mentioned it. I believe it's the fourth, but that's my opinion. Here we have an example of EMP. This is the theory. If there was an atomic explosion 400 kilometers high, practically most of the US would be unable to communicate, regardless of radiation and everything else involved. It's only theory so far. It hasn't been proved. The fourth industrial revolution is robotics, AI, IoT, 4.4 employment, 4.4 industry, quantic computer, genomics, everything that we know today that is growing and developing. Jeremy Rifkin wrote a book in 2011. You can find it on the internet about this fourth revolution. It has very interesting concepts, mainly on what they call the green revolution that has to do with climatic change and everything that is included within the 4.0. From my point of view, this is a trilogy that is going to be changing the world from now on. As internet changed the world in 1995, this is going to change the world today. It involves robotics, artificial intelligence, and quantum computing. Those three technologies are already changing many things in the world. I'm going to start with the first one, that is robotics. Robotics is the one that everybody knows about. It's been around for many years, and it's been developing new topics. We have the typical robotic arm, and we have a robot that is able to acknowledge senses. It's surprised by seeing its own hand, and it can smile, it can get scared. So this already exists. But the difference is that there are robots that are already working in different places, doing different activities. And this has to do with the fact that AI has been growing so much that it allows robots to interact with human beings. As you can see, this is something that was developed that is not available yet. This is quite new. On the 26th of August, the NetDragon website company in China, it's a company that develops video games, and it took a new game. Tang Yun is a robot that is going to change their way of working and their logistics to grow the company. With China, we have a problem. You cannot check news because it's not so easy, but at least the source of this news was good. But there are some other examples. For example, in Korea, primary care in hospitals is done by robots. When you go to the hospital because of a problem that you have, the first responder is a robot. So we have some facts that show that robots can interact with human beings. There are many examples. I'm just giving you one. In the healthcare sector, which is something that we consider complex. So we already have robots operating in the healthcare sector. And now let's talk about quantum computing, which is another key in this trilogy. And here things become more complex, because this has to do with quantum computers and quantum physics, which is something that studies atoms, not in itself, but the particles within the atoms. Very difficult things that we're going to talk about when we talk about AI. IBM has its own quantum computer, System 1. Sycamore is the Google quantum computer. Waze QC is the first quantum computer from Israel. I don't have many data about it. Azure Quantum is from Microsoft. Microsoft has the systems in the cloud, and those can commercially be used, and they offer $500 as credit for those working in the cloud. And it allows to develop the code. You can develop codes and algorithms so that the computer can process them. This is from Canada. It mentions 5,000 qubits. You know that the bits is 1 and 0 or 0 and 1. It's on and off to make it simple. That's a bit. A qubit, which would be the same as a bit, but in quantum computing, has on-off and both together. Since this is kind of difficult to understand, that's why I make it simple as that. It could be on-off or kind of so-and-so. That would be the best way of explaining it, because quantum computers develop statistics. If the computer has something to solve, there's a process. And how do we think? We think yes, no, and something in the middle. This is the way human beings think. And then we reach a conclusion. Quantum computers do exactly the same. They are faced with a problem, they work on it, and they would say, this has 78% of being yes, so we believe the computer thinks it's yes, and if you think it's not, they are going to continue working on the problem. That is the way in which quantum computers work. The more qubits a computer has, the more it can process. That's why here, when they mention 5,000 qubits, it seems kind of strange, because it's generally those numbers are around 20, 40, 60 working together at the same time. This is the Chinese computer that apparently is the biggest in the world. It's the newest. And it can process 10 million times faster than the Google's quantum computer. I don't have the possibility of checking this information, so the Chinese have shown that they do have intelligence capacity to develop important products today. And then the unknowns. How many quantum computers governments have? I can't believe the US government or the Russians or the Germans do not have a quantum computer. The military from different countries, how many quantum computers do they have? Intelligence services. I'm sure that they have already bought quantum computers. Companies, huge corporations, universities. There are some universities that already have quantum computers. Some may be under development, but they do have those computers. So what I have shown you that is like kind of a commercial profile, there's another one that we don't know about, which is the one that I'm showing you. Now we're going to talk about AI. Watson is the easiest way of understanding this. Watson is IBM's AI. IBM offers different courses, training courses on AI that are free, that you can access online, and by taking the training courses, you can have access to Watson. It's for free, and you can develop your own codes and your own AI processes. It can handle 100 algorithms at the same time, and it can analyze 200 million pages in 3 seconds. It's quite interesting, and it's available, and we can all access it, no matter where we are. If I am the owner or the chief engineer of a quantum computer, considering common sense, what would I do? The first thing that I would do would be to ask my computer to create keys that codes that another quantum computer cannot solve. That would be the sense of having a quantum computer, to have some kind of protection. I can't believe that those who have quantum computers are not doing it. And that's why everything that has to do with security in quantum computer is so complex. From my opinion, or my point of view, they have already done it. Some of the ones that I was mentioning have already done it. They do have codes in order to protect themselves some way. Another thing that can be done is to try to break the codes that we already have today, even if it has 256 bits. If I have a quantum computer, I need to try to demonstrate that I can solve the codes that everybody uses. So today, there is no possibility of having a secret in the cloud or on internet with this new technology. I'm not saying that is something positive or negative. I'm just saying that this is the possible future. So, what is going to happen in the healthcare fields, for example? The human genome has already been completed a while ago. There are some labs that have already analyzed everything as regards the human genome. It has been sequenced, and it has a computational capacity to create other possibilities. Quantum computers are going to be solving this immediately. I believe it's like 33 billion genomes, and for a quantum computer, it's like nothing, a couple of seconds. So it would be logic to ask a computer to develop a human being that can swim underwater like the fish do. So I believe this is limitless. The limit is the human factor. We know that we are internet, and we are very good and very bad. So who are the humans that are going to be handling these technologies? It's going to depend on all of us. And that is a future challenge that we are going to be facing. I'm talking about the possible future, which was the title of my presentation. Engineering developments are going to be fantastic, but another problem that we are going to face is employment. I was talking about labor and employment in the second school that we organized, when I was saying that employment as itself is going to disappear. And when I finished my presentation, I had a psychiatrist waiting to ask me what this was about. They still do it, but they want to ask me about the patients that they are going to be taking care of. If you check the ILO's page, we are going to see that every year there's 80 million unemployed. The numbers are astonishing, but it is interesting that there's only one country in the planet that is really analyzing this, Finland. There's a retirement system in Finland by which any citizen in the country, for example, a 25-year-old person wants to retire, they are going to receive an allowance and they retire and they do whatever they want. They can do it forever, or they can come back after a while, because they already know what is going to happen. So they are already implementing this method. Governments all over the world have too many problems to think about the problem of employment. They do know that it's going to be a problem, but it's only a possibility so far. Being unemployed could be something not so negative. I can do whatever I won't need to work, but there should be some kind of way of living, some benefits that I should receive in order to continue living. I was talking about the possibility of internet offering possibilities such as being a poem or a singer, but this would be without working. And I believe there's a huge problem because human beings are not ready to enjoy free time. And there's going to be a problem for psychologists because there's going to be a cultural shift when people won't need to work. In France, there was an experiment that involved working only 4 hours a week. It was chaotic because they had too much time, too much free time. They didn't know what to do. So they had to go back and to work 40 hours a week. So I believe that's a huge challenge. What is society going to do if they don't have to work? Some food for thought. Not everything is so negative. When you can ask a robot to wash the dishes, it's going to be so interesting. Or to tidy the house and the things that you don't want to do. Yeah, there are already vacuum cleaners that do it. And now I'm open to questions. A round of applause for Oscar.
Oscar, I have an engineering question for you. I studied electronic engineering, and I know how you create a bit, which is use a bit of silica, and some other chemical products. But what are those hangy things physically? Do you know what happens? What goes on in the computer? You know, there are these wires, and it looks like some kind of funny monster. I haven't had the time to research this. That has to do with certain basic problems. Quantum computing needs very low temperatures, almost 0 degrees. So these machines, what they do actually is just lower the temperature. Quantum physics is really weird. Processing using quantum physics has quite a complex problem, but they're trying to solve it. Basically, when you look at the results, they change, right? That's quite difficult to grasp. So it's very complex to get a result from a quantum computer because it's based on quantum physics. And in quantum physics, quarks and those little bugs which are running around inside the atoms, they're so tiny. If you measure them, they change. They change state. That's a problem. Even so, we are getting results. And the other thing is, the qubits, it's not that complex. Because as you have three options, so I'm very curious about this. I haven't really had time to go into this in greater depth. Anyway, when you have yes, no, and perhaps, at a statistical level, you can analyze this more easily. Because it's not really just a perhaps, it's lots of perhapses. I don't know if you've seen a little circle, a funny little circle picture, which is like the graphic of a qubit because it's constantly changing. And as it's quantum, once it's achieved a certain degree of definition, you should be able to read it and save it. But it changes. In Latin America, I know that there are several in China, Europe, the States. We don't think we have any in Latin America yet. Any questions for Oscar? No, lots of questions. I have books and books on this subject. Hi, I'm from the Avicenna University. Thank you very much for taking the time to give us a timeline, to tell us about the beginnings of internet, because it helps to show us where we've been and where we want to go. In terms of what you were saying, it seems that the focus or the biggest challenge we face in this aspect of quantum computing, that the main challenge is also one of information systems security, because this is like a silent war, right? The whole business of security. I think there is a gap as regards the transformation of jobs in the future. We might not have as much free time as we think, as we will have to dedicate ourselves to security of our systems. Now, the question is, where do you think it's that quantum computing will have the most impact? Tough one. I don't think there's going to be a single sector that will be left out. Probably it will grow more in the areas where it's obviously going to be more profitable, right? That's the way we work. But I think at the moment, those who are using it are the original laboratories, like the vaccines. Making vaccines will be instantaneous. So bugs and viruses will have to watch out. The second wave of COVID, it's amazing, actually. A vaccine has never been prepared in such a short time, and that was the result of computing. And that's all going to grow. Oscar, that was incredibly interesting. I've had the opportunity to talk about the future of work and the fear that certain jobs are going to disappear In my country, for instance, we used to have the milkman who would deliver milk to each door, and that's changed. And we're going to see the same thing in this sector. Technology is going to make certain functions disappear, and that means that we will have to evolve, develop, and specialize. How do you see this in terms of this possible future that you laid out for us? Exactly. The thing is the speed at which these things happen. For instance, the milkman stopped delivering milk because there was a truck and then there was the supermarket. That took time, but this is going to go a lot faster. Now, let's look at industry in general. If I have a factory where I have, say, 10,000 employees, and tomorrow, thanks to quantum mechanics, quantum computing, robotics, and everything, I make it completely automatic, and I just employ 10 employees. The other 999 or 990, do you know any businessman who's going to say, I'm not going to pay my workforce anymore, so I'm going to give all the people I'm sacking a monthly allowance, which is going to be far less than everything I'm learning. And that actually should be the task of the government, not the company, right? That's the challenge we face. What are the governments going to do about it? Not industry. Well, let's make this a very short one because we have our next panel ready and waiting. Within the trilogy that you talked about, we're all talking about quantum computing. Many people are going to tell us that this is going to kill ciphering, encryption. But is this going to reach our homes? Or is it going to be like with the beginning of computers, when people hardly had any at all? I mean, what's going to happen? Or is it going to be like PCs, which originally started out being used in companies and then made their way into people's homes? What's going to happen? Well, there are lots of answers here, but there is something important. Something that happened quite recently, about a week ago. I really haven't had the time to look into it, but Intel said that it's just produced its first quantum chip. Now, if that's true, you will have one in your cupboard in no time at all. Right, and a round of applause for Oscar. Thank you very much. Thank you, Oscar.